These are the lesson 3.1 notes on parallel lines and transversals. Let's start with a little bit of vocabulary. Parallel lines are lines in the same plane that do not intersect. You are familiar with the idea of parallel lines, that if you take two lines like railroad tracks or a road and you extend them and they go on and on and on without intersecting. That one looks like it might intersect. They are parallel. When we talk about being in the same plane, a plane is a flat surface. So you can imagine that if you had two, can you see them up in the air? I could have things that didn't intersect that are not parallel because these are not in the same plane. They're not in the same flat surface. Now they're parallel. Now they're not, even though they won't intersect like that. All right. A perpendicular line is a line that intersects at a right angle. I want to add a little picture here. Remember from one of the activities that we did that you can show that lines are parallel. The little symbol for that is a little triangle. All right. Perpendicular lines are lines that intersect at right angles. And we learned from our activity today that if this is a right angle, then the one that is vertical to it is also right. And the one that is adjacent to it is also a right angle because it is on a straight line. And so when two lines intersect at one right angle, that means all of the angles are right angles. A transversal, this is a new word. You may have heard parallel and perpendicular, but transversal is probably new. A transversal is a line that intersects two or more other lines. And we can just draw a little quick picture. We're going to pretend those are parallel, and there's a transversal. But the lines do not have to be parallel in order for the intersecting line to be a transversal. Right? Okay. Big key idea here. We've got a lot of vocabulary in all of chapters 12 and 3. The idea of corresponding angles. When angles are corresponding, it's like you could take one and slide it up to the other. Corresponding angles are equal to one another. So when a transversal intersects parallel lines, then the corresponding angles are congruent. So you can see that they are marked differently, like this one has, I think yours might be in color if you're looking at it on the screen. That is corresponding to that, and they are equal. And this with the little 2 lines is equal to this one. We know that that is also equal to that because they are vertical. Let's see if I have some more colors here. And this one is equal to this one. Those correspond. And I wonder if I got one more. And that's got 3, and that one's got 3. All right. So showing that if you could just slide one on top of the other one, they would be corresponding. It's the same angle, just in a different spot, and they are equal to each other if the transversal is crossing those parallel lines. So then we can use this figure to find the measures of angle 1 and also of angle 2. So the picture shows us that line A and line B are parallel because they're marked as parallel. And here we have this transversal. And so I know that if corresponding angles are congruent, then I know that angle 1 is equal to 110 degrees because it is corresponding. So we need to put the reason why. All right. And then if angle 1 is 110, then I know that angle 2 is equal to 70 degrees because it is supplementary to angle 1. I know that 110 plus 70 is equal to 180 degrees. Okay, that's what supplementary means. All right. Okay, then you have two U-tris. You have a similar picture with parallel lines and a transversal, and you have to find the measure of angle 1 and angle 2, given that this angle is 63 degrees. You need to put the answer and also the reason, whether they are vertical angles or corresponding angles, whether it was supplementary. You'll do a lot of that when you get to geometry in high school, learning to prove or to support your answers. You can't just put down an answer, you have to put why or how you know. All right, so now we're using corresponding angles and doing the same thing. Again, we have parallel lines cut by a transversal, and we're going to find the measures of all of those angles. All right, so we're going to start with angle 1. And if we were in class, I would say, what's the measure of angle 1? Angle 1 is equal to 75 because it is vertical to a 75-degree angle. Let's see, and from there, we can go to 2. Angle 2 then is supplementary to angle 1, so it must be 105 degrees. 105 plus 75 is 180. Supplementary. There we go. All right. And then angle 3 is vertical to angle 2. And then let's see, angle 4. Angle 4 is corresponding to angle 1, so it must be the same as angle 1. Does that make sense? Angle 4 is 75. And from there, it kind of follows the same reasoning. I would go from there to 6. And I would say that it is also 75 degrees because it's vertical. And then I would probably come down to 7 or over to 5. I could do 5. And those have to be 105 because it's supplementary. You could also recognize that 6 is corresponding to this 75. So you could pop straight out to 6. Once you get 2, you should recognize that 2 and 5 are the same. 2 and 5 were the same. What haven't we done yet? 7. And 7 is also equal to 5, so it is 105. We got lots of different reasons for that. So lots of times there will be multiple reasons why, and that's a nice way to check your answer. So if you find it 2 different ways and you get the same answer, then you know it's right. So I might want to check and say, okay, 1 and 4 should be the same, and 3 and 7 should be the same, 6 should be 75, and 2 and 5 should also be the same. All right, so all of my corresponding angles are the same, and it checks out the same as using vertical and supplementary angles. I always find these fun. It's just like little puzzles, but they're not too hard. And then when you get into geometry, it gets harder and harder, but your brain will be ready for it by then. So, all right, so going on to The next big idea is that when you cut parallel lines with a transversal, you're going to create two different kinds of angles. You have some angles that are interior angles, like the interior of your house, they're inside. And then you have exterior angles on the outside. Angles 3 and 4 and 5 and 6, they're on the inside of the parallel lines. Those are interior angles. And angles 1 and 2 and 7 and 8, they're on the outside of the parallel lines. So those are the exterior angles. We're going to learn a little bit more about those in just a minute. All right. Now we have a little, not very real life, but anyway. A store owner uses pieces of tape to paint a window advertisement. The letters are slanted at an 80-degree angle. What is the measure of angle 1? All right. So you can use the idea that this angle, these are parallel lines, right? And they are cut. So these two parallel lines are cut by a transversal. So this angle corresponds to this angle, which must mean that this one is also 80. So if this angle is 80, then angle 1 must be 100 because it's supplementary. Okay. All right, then you have a similar U try. And then taking that idea of interior and exterior angles one step further. So this is just a shortcut. All right, to learn a little shortcut here. When a transversal intersects parallel lines, the alternate interior angles are congruent and the alternate exterior angles are congruent. You can see that just by looking at it, and your hunch, your intuition is correct. When you've got these two lines cut by the transversal, these are interior angles. When you say they're alternate, they're like the opposite side. So this one is equal to this one. You can tell that by looking at it, and you could also figure it out because this angle would be equal to this angle because it's corresponding, and then it's vertical to this angle. So these alternate interior angles are equal. And the other side is true as well. If this angle corresponds to this angle and is vertical to this angle, then these alternate interior angles must also be equal, right? That shortcuts so that instead of having to say corresponding and vertical, you can just say alternate interior angles are equal. And the same reasoning holds true for alternate exterior angles. So you've got an exterior angle on the top, and it's opposite down here on the left. These are equal. And the one on the top left is equal to the one on the bottom right. These opposite exterior angles are equal. And it's the same reasoning as before. If you have this angle would be corresponding to this one, and then it's vertical to this one, so they're equal. And this angle corresponds to this angle, and then it is vertical to this angle, so they're equal. It just lets you shortcut instead of having to give two reasons why, two steps. You can just give one step. Right? And then we can use that, let's see, identifying alternate interior and exterior. So here we have a little portion of an airport. Describe the relationship between each pair of angles. So we're going to look at angle 3 and angle 6. Here's 3, and here is 6. So these are my parallel lines, and they're cut by this transversal. I guess I should use a different color, huh? Then angle 6 here and angle 3, they're on the outside of the parallel lines, so they're exterior, and they are opposite or alternate exterior. And then angle 2 and angle 7, let's see, maybe we can use the green one. Here's angle 2, and here's angle 7. They are on the inside of the parallel lines, so they are interior angles, and they are also alternate. They are on opposite sides. The ones that are on the same side that aren't alternate, those are not equal. You can tell that those aren't equal. I think they're actually supplementary to one another, right? So angle 2 and angle 7 are alternate interior. Okay. And then you have a whole piece of paper devoted to 3 small U tries. You will have to go back and look at that same picture again. And that's all.